You guys are on text page 227, and your blue notebook page is 213. We're on lesson 4.4. I needed you guys to get this down, discriminant and need to know. Yesterday, we were dealing with this equation here. I can use that. Quadratic formula, okay? Today, we're dealing with something called the discriminant. So, today we're dealing with the discriminant. The discriminant is this formula here. In fact, it is a part of the quadratic formula. If you guys take a look, this part of the quadratic formula is the exact same as our discriminant. The discriminant is going to tell us how many roots something has. Okay? So our parabola has a certain amount of roots. The discriminant uses the exact same letters we were using in our quadratic formula before. They have a b, which represents this number here in our standard form, an a, and a c. So when looking at a formula in our standard form, our numbers that represent a, b, and c are still the exact same. The reason we're doing this is to find out the amount of roots. And what I mean by that is if I go to draw a parabola, how many roots does this parabola have? Anyone know? 2. Roots are our zeros or our x-intercepts. So this parabola has 2 of them. What about this one? How many roots does this one have? 1, exactly. It just touches the x-intercept, so it only has 1. And finally, this parabola here, how many roots? 0. It doesn't cross the x-intercept, therefore it has 0. So, 2 roots, 1 root, and 0 roots. Now, normally if we're in standard form, we'll have to change it, maybe factor form, to kind of figure out how many roots our parabola is going to have. This is a quick way of doing it. If I ask you how many roots a parabola has, if you plug these numbers into our discriminant, depending on what comes out, will tell us how many roots we have. So I'll explain that again. We'll go down and do an example. Example number 2, is it? No, 1A. 1A. Oh, you don't need. So in your book, your discriminant, I just realized, looks like this. It's just b squared minus 4ac. It doesn't actually matter if we have a root over it. We're still going to end up with the same answers. So the one they've given me in the program has a root over it. I'll explain why it doesn't change anything as we go down. So we're going to do the very first question here. We'll do 1A. 1A gives us this formula, negative 2x squared minus 3x minus 5. Okay? And it's equal to 0. So our values for our standard form, sorry, that's supposed to be a plus. We have our A, B, and C. Which number represents C? Negative 5. What about B? Negative 3. And A? Negative 2. Good. So we know what all those values are. We're going to use both formulas, the one that they've given us in the program and the one they've given us in the book, to see that it doesn't matter which one we use. We're still going to get the exact same answer. So, first of all, your book gives you b squared minus 4ac. That is just their formula. We're going to plug our numbers in. So for b, we had negative 3. So we have negative 3 squared subtracted by 4. A is negative 2. And C is negative 5. Let's evaluate this. 3 squared is 9. Negative 4 times negative 2. Anyone know? 8. 8 times negative 5. Negative 40. 9 subtract negative 40. Negative 31. So I know you guys wrote down your key concepts. If our discriminant ends up being a negative number, how many roots are there? 0. Very good. If this number is negative in the formula they've given you, we're going to have 0 roots. So that means we have some parabola maybe opening like this. Or actually, in fact, since it's negative, I know it's not going to open like that. I know it's going to be a parabola that is below the x-axis. Because it's negative, it's going to be opening downwards. And the only way for a parabola to open downwards and not have roots is if the vertex of that parabola is below the x-axis. So it's something like this. It could be this one here. We just know it's going to be facing downwards and below the x-intercept. Okay, so let's keep going here. The formula they gave us in the program, if you guys remember, was the exact same except for one minor detail. They have a square root sign above. Okay? So let's say we do the exact same thing. I'm going to leave it in black because we've already seen the numbers before. Negative 3 squared minus 4, negative 2, negative 5. Roots. 9 subtract 40. And what's going to happen? We're going to have the root of negative 31. Now this one actually kind of makes more sense. Am I able to find the root of negative 31? No, there are no roots of negative 31, hence why this would be 0 roots. So whether you guys use the discriminant they've given you in the book, or the one where we have the square root over it, either way, you're not going to be able to have any roots to this number, therefore you're going to have 0 roots. Okay, so we're going to go to example 1b. I'm going to quickly underline. Here's our A. What's our B? What number is that?
1. Negative 1.
Negative 1. Good. And what is C? Negative 6. Good. Negative 6. So we're going to go plug it in. We're going to plug it into the original one they've given us. Okay? And we'll do the one also that this program gives us. So formula they've given us is b squared minus 4ac. So we have our b squared minus 4ac. Plug in our numbers. B is negative 1. Squared, subtract 4. A is 2. No, that is not the color I wanted. And C is negative 6. All right, so let's equate this. Negative 1 squared is 1. Negative 4 times 2 is negative 8. Negative 8 times negative 6 is positive 48. Our answer ends up being 49. Once again, because I know you guys wrote down the key concepts, if we have a positive answer, how many roots do we have? 2. That's right. There are 2 roots. Now I know this is positive, so this is going to be a parabola that opens upwards. So that means I have some parabola where the vertex is below the x-intercept. Might be just below, might be very much below. Something like that. We know it has 2 roots. It's going to cross the x-intercept twice. We'll keep going. Okay, so their formula, like we said before, it's all the only difference is they have a square root. Whoa. So, same formula. I just can't write it as well, that's all. Let's see. We'll write the same numbers in. So, the root of negative 1 squared minus 4 by 2 by negative 6. Now, what do we already know the answer is going to be underneath the square root? It's going to be 49. I really don't have to equate all that. Can I find the square root of 49? Yeah, this one ends up being a whole number. What if it was 48? Can I find the square root of 48? I can. It just won't be a round number. It'll have some decimals to it. As long as I can find the square root of the number, and it's not 0, I'm going to have 2 roots. Okay? I have 2 roots. Okay. And finally, the third type of example we're going to go through. Now, they've given us in 1C, x squared minus 10x equals negative 25. In order to use our discriminant formula, we need to be in standard form. So what that means is I need to set this equal to 0. I'm going to move the negative 25 over to the other side of the equation. So our equation will now be x squared minus 10x plus 25 is equal to 0. When the formula is set out like this, I can tell what my A is, my B, and my C. And what's my A going to be, just so we know? 1. We know there's a number 1 there. Okay, we now have our A, B, and C. So that's going to let you know in your homework, if you're given other forms, maybe factored form or vertex form, you're going to have to change it to standard form and able to use this discriminant. Okay, guys? So let's keep going. Discriminant formula. We'll plug these numbers in. B squared minus 4AC. Our B is negative 10. Squared minus 4. A is 1. And C, that's not C, it's 25. Negative 10 squared is 100. Negative 4 times 1. Anyone know? Negative 4. And negative 4 times 25? Negative 100. So what is 100 subtract 100? 0. If our number is 0, how many roots do we have? 1. This means there is 1 root. So in other words, now I know this is positive, so this is some parabola where vertex is on the x-axis. That means there's only 1 root. It's only touching it once. Could be like this. Could be upside down. We know this is positive, so we know it opens upwards. Okay, well, there's your homework. Blue notebook. It's on page 213. Textbook 232, 410, 12, 13.